Section 5.4 is solving radical equations. So up at the top, there's 3 steps that you can follow to solve radical equations. The first one is to isolate the radical on one side of the equation if necessary. The second one is to raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. And the third one is to solve the resulting equation and then check our solutions. So for the first example, the square root of 1 minus x equals 7. So the first step is to isolate the radical on one side of the equation. So our radical is isolated already. So there's nothing that we can like add or subtract over that's outside of the radical or multiply or anything like that. It's isolated. So as soon as it's isolated, we can move on to step 2, raise each side of the equation to the same exponent to eliminate the radical. So because this is a square root radical, we're gonna square both sides to cancel out that radical. So squaring both sides is going to cancel out the radical, and on the left side is just going to leave me with 1 minus x, and then equals 7 squared, so 49. And then after that I need to subtract the 1 over. I end up with negative x equals 49 minus 1, so 48. And then I need to divide both sides by negative 1 because I don't care what negative x is, I want to know what positive x is. So if I divide both sides by negative 1, 81 becomes negative 81. And then from there we need to check our solution. So a lot of the solutions you can kind of check in your head. So 1 inside the radical, 1 minus x, so 1 minus negative 48 turns into 1 plus 48. So 49 inside the radical, the square root of 49 is 7, so we're good. And then for example 2, the cubed root of 5x plus 1 equals negative 4. So our radical is isolated, so we're good there. There's nothing outside of the radical on this side of the equation. And this is a cubed root radical, so that means that we need to cube each side or raise each side to the third power. So raising this side to the third power cancels out the radical, and then I'm just left with 5x plus 1. And then negative 4 to the third power, I'm raising all of negative 4 to the third power. So negative 4 times negative 4 would be positive 16, and then times another negative 4 would be negative 64. And then from there, I'm solving for x. So I'm just trying to isolate x, so I'll subtract the 1 over. And then I have 5x equals negative 65. And then from there, to isolate x, I need to divide both sides by 5. So we end up with x equals negative 65 divided by 5 is negative 13. And then we can start to check it in our head. So 5 times negative 13 is negative 65, plus 1 is negative 64. The cubed root of that is negative 4. So we're good. For example 3, now our radical isn't isolated, so we have 1/4 times the 4th root of 2x plus 6 outside of the radical equals 10. So you isolate it kind of following the same steps you would like for pretty simple equations like you learned in 8th grade Algebra 1. We want to isolate the square root or the 4th root of 2x, so the first thing that I can do to isolate it is I can subtract this 6 over. So then I have 1/4 times the 4th root of 2x equals 10 minus 6, so equals 4. And then now I need to cancel out this 1/4. So in order to do that, I can multiply both sides by 4. So 4 times 1/4 is just 1, so those cancel each other out. And then I'm left with the 4th root of 2x equals 4 times 4, so 16. And then now I have the radical isolated, so in order to get rid of the radical, I need to raise each side to the 4th power since it's a 4th root. So raising the left side to the 4th power just undoes the radical, and I'm left with 2x. And then 16 to the 4th power is 65,536. And then to solve for x, I need to divide both sides by 2. So 32,768 is our x value. And then this one we can not necessarily check in our head, but we can do some of the work in the calculator. So x was 32,768 times 2 gets me back to 65,536. And then I want to take the fourth root of that number. So if I want to take the fourth root of something, I have to hit 4, and then second, and the little square root with the x. So this is the fourth root of 65,536. And then that's 16. And then I can multiply that by 1/4, or I can divide it by 4. Either way works. And then add 6 gets me back to 10. And then for number 4, so 2 times the cubed root of 13x minus 5 equals 10. So right now my radical isn't isolated. The only thing that is being done with those, there's a 2 multiplied by it. So in order to undo that 2, I'm going to divide both sides by 2. And then the 2's cancel each other out. I'm left with the cubed root of 13x minus 5 on the left side. And then 10 divided by 2, so 5 on the right side. And then now my radical is isolated, so to undo it, I can raise both sides to the third power since it's the cube root. The third power cancels out the radical, and on the left side, I'm just left with 13x minus 5. And then equals 5 cubed, so 5 times 5 times 5 is 125. And then from there, I just need to move everything away from the x. So I'm going to add 5 to both sides in x. So that would be 13x equals 130. And then if I divide both sides by 13, I end up with x equals 10. And then to check it, so if I plug in 10 for x, 13 times 10 is 130, and then minus 5 is 125, and then if I take the cubed root of that, the cubed root of 125 is 5, 2 times 5 is 10, so we're good. And then for number 5, so the square root of x minus 5 equals x minus 7. So the radical is isolated, so I can go ahead and square both sides to cancel out the radical. But because there's multiple terms over here, I'm going to have to put them in parentheses and then eventually FOIL. So the squared cancels out that square root, so I'm left with x minus 5. And then the x minus 7 is a binomial squared, so x minus 7 times x minus 7. The x minus 5 can't be simplified further for right now, so I'm going to leave it alone. And then the x minus 7 times x minus 7, if we FOIL that, it turns into x squared minus 14x and then plus 49. And then now I'm going to have a quadratic, so I want to get this in standard form. Since I have the x squared, I want to get it in standard form. So I'm going to subtract x over and add 5 over. So these cancel out. I'm left with 0 equals x squared. Negative 14x minus x becomes negative 15x. And then 49 plus 5 becomes 54. And then now I need to solve it by factoring. So I have to think, are there factors of positive 54 that add up to negative 15? So it would be negative 9 and negative 6. So that means that x squared minus 15x plus 54 factors into x minus 9 times x minus 6, and then we can set each factor equal to 0. To solve for x, and then we end up with x equals 9 and x equals 6 as our solutions, and we need to check both. So for x equals 9, so 9 minus 5 inside the radical would be 4, and then the square root of 4 is 2. And then 9 minus 7 is also 2. So we're good there. So the 9 is fine, we've checked it. But for the 6, if I plug in 6, 6 minus 5 is 1. The square root of that is positive 1. But then 6 minus 7 is negative 1. So the 6 doesn't work. And you don't have to always check in your head. You can definitely check, like, just write it off to the side. So if I plug in x equals 6, this becomes the square root of 6 minus 5, and then that would be equal to 6 minus 7. And then the square root of 6 minus 5, so 6 minus 5 is 1. The square root of that is also 1. But 6 minus 7 is negative 1. So that check doesn't work. So that means that x equals 6 is an extraneous solution. And then for number 6, the cubed root of 486 minus 27x cubed equals 3x. So now our radical is isolated. There's nothing that we can cancel out on the left side. So I can raise both sides to the third power since this is a cubed root. The 3x needs to go in parentheses because both the 3 and the x will be raised to the third power. So the third power cancels out the third or the cubed root radical. On the left side, I'm just left with 486 minus 27x squared, or x cubed, sorry. And then 3x cubed means that the 3 is being cubed and the x is being cubed. So 3 cubed is 27, and then x cubed. And then now we have, well, we have just like a constant, and we have a 2 cubed terms. So this one would make the most sense to solve by just taking the cubed root. So we would want to get our cubed terms together. So I want to add 27x cubed to both sides to move these together. So the 486 stays on the left. These cancel out. 27x cubed plus 27x cubed becomes 54x cubed. We just need to add the 27s together. And then now I want to isolate the x cubed part so that I'm able just to take the cubed root to solve. So I have to divide both sides by 54. And then these 54s cancel out. 486 divided by 54 is 9. So I'm left with 9 equals x cubed. And then I can take the cubed root of both sides to get x by itself. So I end up with x equals the cubed root of 9. So we can't simplify it. There's no like perfect cube factors that we can pull out of that. So we're good, and we can stop there if it cannot be simplified. If we want to check it, this would x being the cubed root of 9 would go in here. And on the right side technically too, but on the left side, if I cube this x, if I cube the cubed root of 9, the cubed and the cubed root cancel out and I'm just left with 9. So this becomes 486 minus 27 times 9. So 27 times 9, or I could do 486 minus 27 times 9. So that's 243. And then I'm taking the cubed root of the left side, so I have to take the cubed root of 243. And then that's about 6.24. Try to just keep that, or you can make a note for yourself that this was about 6.24. And then from there, I'm multiplying 3 times the cubed root of 9. So I can find the cubed root of 9 first and then multiply it by 3. So 3 times the cubed root, or sorry, the cubed root of 9 right here, and then we'll multiply it by 3. So that was the 6.24 number also. So even though they're like weird decimals, both sides are equal. And then for number 7, so 4 times the square root of x plus 1 equals x plus 1. So I need to isolate the radical first. Right now 4 is being multiplied by the radical. So I'm going to divide both sides by 4 to cancel out the multiplying by 4. These cancel out. I'm left with just the square root of x plus 1 equals x plus 1 over 4. And then now that the radical is isolated, I can square both sides. So the x plus 1 over 4, that needs to go in parentheses. That can't be simplified at all. We might be able to later, but right now it can't. So both of these need to get squared. So on the left side, the squared cancels out the radical. I'm just left with x plus 1. And then on the right side, the x plus 1 over 4 squared. I'm going to have to square the x plus 1 and square the 4. So that's going to look like in the numerator x plus 1 times x plus 1. And then in the denominator, 4 squared is 16. So we're going to leave the left side alone for right now. So just x plus 1 and then work on simplifying that fraction. So x plus 1 times x plus 1 in the numerator, if I FOIL that, it turns into x squared plus 2x plus 1, and then over 16. And then from there, I kind of want to get rid of the 16 in the denominator, so I'm going to multiply both sides by 16 to cancel it out. I just have to make sure that I distribute the 16 on the left side to both of these terms. So on the left side, 16 times x is 16x. 16 times 1 is 16, so plus 16. And then on the right side, this 16 just cancels out the 16 in the denominator. It does not change the numerator. So that's still x squared plus 2x plus 1. And then now we have a quadratic. We have the x squared, so we want to get this in standard form. So I'm going to subtract the 16x and the 16 over. So minus 16x minus 16. These cancel out. I'm left with 0 equals, I'm going to bring down the x squared. 2x minus 16x becomes negative 14x. And then 1 minus 16 becomes negative 15. And then from there we need to factor it. So I'm thinking of factors that multiply to negative 15 and add up to negative 14. So that would be negative 15 and 1. So it would be x minus 15 times x plus 1 for my factors. So negative 15 times 1 is negative 15, and then negative 15 plus 1 is negative 14, so we're good there. And then if we set each factor equal to 0 to solve, we end up with x equals 15 and x equals negative 1. And then we can check both of those. So for x equals 15, if we plug the x equals 15 in, 15 plus 1 is 16. The square root of 16 is 4. So 4 times 4, I have 16 altogether on this side. And then on the right side, I have 15 plus 1, so I have 16 on this side, so I'm good. Like I said, you can always leave yourself a little note, like what you got on each side to check it. And then for negative 1, 4 times the square root of negative 1 plus 1. Negative 1 plus 1 is 0. The square root of 0 is still 0. Times 4 is still 0. So the left side is 0. And then negative 1 plus 1 is also 0. So we're good on both of those. And then for number 8, so the square root of 2x plus 2 minus 3 times the square root of x plus 1 equals 0. So right now we have two radicals on one side. So when you have two radicals on one side, it's usually your best bet to move them on opposite sides. So I'm going to add the 3 root x plus 1 to both sides to cancel it out on this side. And then when I do that, my new equation is the square root of 2x plus 2 equals 3 root x plus 1. And then from there, now the radicals are technically isolated on each side, so I can square, well, they're as isolated as they could be. I know this 3 is here, but the only way to get rid of this 3 is to divide it on both sides, and then it would end up over here. So you're just kind of moving it around at that point. So I can go ahead and square both sides now. So on the left side, squaring ends up canceling out this radical, so I'm just left with 2x plus 2. And on the right side, the squaring it is going to cancel out the radical, but I'm also squaring the 3. So the 3 squared becomes 9. And then squaring the radical cancels it out, so 9 times x plus 1. And then we do need to distribute the 9, so 2x plus 2 equals 9 times x, so 9x, and 9 times 1, so plus 9. And then we don't have a quadratic, so like our goal here, or we just have like x to the first power. Our goal here is just to get the x's together and then isolate them. So I can subtract 2x from both sides to get my x's together. These cancel out. And then I'm left with 2 equals 9x minus 2x is 7x plus 9. Now I can isolate my x. I can subtract the 9 over. 2 minus 9 is negative 7 equals 7x. These cancel out. And then divide both sides by 7, and you end up with x equals negative 1. And then if we check it really quick, 2 times negative 1 is negative 2, and then plus 2, negative 2 plus 2 is 0, so this is the square root of 0. And then minus 3 times negative 1 plus 1 is also 0, times 3 is still 0, so 0 minus 0, we get 0, and we're good. For number 9, it's the square root of x plus 7 plus 2 equals the square root of 3 minus x. Ignore like the pencil marks because I did change my mind on how I wanted to do it. Okay, so usually our first step is to isolate the radical. There's not really a way to fully isolate each radical here, because say I want to isolate this radical and subtract the 2 over, it's going to leave this radical not isolated. So this is probably one of the like harder types of problems from this section. So whenever we're in this situation where there's no real way to isolate the radical, we kind of just need to go ahead and square both sides right then and there, or cube, depending on what the type of radical it is. So I'm going to square the left side, including the 2, and I'm going to square the right side. So in order for like these equations to stay true, we have to square everything on each side, so we have to include the 2. And because this is now 2 different terms, so like there's the radical term and the 2 term, because it's multiple terms, I'm going to have to write it side by side and FOIL it, because I can't just like distribute this squared in, because of the plus sign creates the 2 different terms, and we have to FOIL. So the left side becomes the square root of x plus 7 plus 2 times the square root of x plus 7 plus 2 again. And then on the right side, this square does just cancel out the radical, so I'm just left with 3 minus x. And then now we'll have to FOIL this left side like I said. So the square root of 7 times the square root of x plus 7 times the square root of x plus 7, the first 2 terms. If you're thinking what that looks like when you multiply those 2 together, it would be anytime you multiply something by itself, you're squaring it. So that would become the square root of x plus 7 squared. And we know the squared cancels out that radical. So when we multiply these 2 together, we're just left with x plus 7. The radical cancels out. And then when I multiply the square root of x plus 7 times 2, that becomes 2 times the square root of x plus 7. And then I have another 2 times the square root of x plus 7, so that becomes 2 times the square root of x plus 7 again. And then 2 times 2 for my last 2 terms, that gets me plus 4, and then equals 3 minus x. And then from there we can go ahead and we can combine like terms. So we have a 7 and a 4 that we can obviously combine on the left side, but we also have this radical term because both of the numbers inside the radical are exactly the same, so they're pretty much like terms. So like the 2 root x plus 7 and the 2 root x plus 7, because they're both x plus 7 inside the radical, we can add them just by adding the coefficients to 2's. So this left side becomes x, and then plus 7 and 4 gets us to 11. And then 2 root x plus 7 plus 2 root x plus 7 becomes 4 root x plus 7. And then equals 3 minus x. And then now that we're at this point, this becomes a problem kind of similar to like the ones earlier on in the notes, where our first step technically is to isolate the radical. It just took us a little bit to get there. So now we can isolate this square root of x plus 7. We can subtract the x over and subtract the 11 over. So make sure you subtract the 11 from the 3 and the x from the negative x. So these cancel out. And then I'm left with the 4 root x plus 7 on the left side. And then equals 3 minus 11 is negative 8. And negative x minus x is negative 2x. And then from there, for isolating the radical, we can technically divide both sides by 4 to fully isolate it, but then we're going to have to, we'll end up with a fraction over here. So this is where it's kind of up to you. You can divide by 4 on both sides to fully isolate the radical and then just deal with the fraction. Or if you want, we can just go ahead and square both sides now. We just have to make sure that we also square the 4. And I would say because there's multiple terms over here, and we're going to have to FOIL, you probably don't want to FOIL the fraction, but it's up to you. And then, so if I square the 4, that becomes 16. If I square the square root of x plus 7, that just becomes x plus 7. And then on the right side, I'll have to FOIL that again. So negative 8 minus 2x times negative 8 minus 2x. And then I'll distribute on the left side, so 16 times x is 16x. 16 times 7 is 112. And then on the right side, negative 8 times negative 8 is 64. Negative 8 times negative 2x is positive 16x. And then we have another negative 2x times negative 8, so it's another positive 16x. So together that's positive 32x. And then negative 2x times negative 2x becomes positive 4x squared. And then now we have a quadratic. It looks a little wonky because it's out of order, but we can get it in standard form and we can solve. So I'm going to subtract the 16x from both sides, and then subtract the 112 from both sides. So these cancel out. I'm going to reorder it a little bit so the 4x squared comes first. And then 32x minus 16x becomes 16x. And then 64 minus 112 is negative 48. So we have 4x squared plus 16x minus 48. And then you might notice that all of these numbers are divisible by 4. So you can either factor out a 4 to make it easier, or you can just divide it out since it's an equation. So if I divide out a 4, I'm left with 0 equals 4x squared divided by 4 becomes x squared. 16x divided by 4 becomes 4x. Negative 48 divided by 4 becomes negative 12. And then from there, we're just looking for factors of negative 12 that add up to 4. So it would be 6 and negative 2. And then 0 equals, since it's 6 and negative 2, it factors into x plus 6 times x minus 2. And then if we set each factor equal to 0 and solve for x, we end up with x equals negative 6 and positive 2. And then from there, we do need to check it. So remember, like, this wasn't squared or anything before. So if we're checking the negative 6 plus 7 is 1. The square root of 1 is still 1, plus 2 is 3. So I have a 3 on the left side. And then 3 minus negative 6 is like 3 plus 6, so that's 9. The square root of 9 is 3, so I have a 3 on the left side and on the right side, so the 6 is good. And then for the 2, so 2 plus 7 is 9. The square root of that is 3. 3 plus 2, so I have a 5 on the left side. And then 3 minus 2 is 1, and the square root of 1 is definitely not 5. So that negative 2 answer doesn't work. It's extraneous. So just x equals negative 6 is our solution. And then for number 10, 1/2 times x to the 5/2 power equals 16. So now we have like it raised to a rational exponent. So we do still want to isolate that like x to the 5/2 power. So we can cancel out this 1/2 by multiplying both sides by 2. So multiplying the left side by 2 cancels out the 1/2, and then I'm left with x to the 5/2 power equals 16 times 2, so 32. And then I have to use like the properties of exponents, specifically like the power property, in order to basically like not cancel out, but get this 5/2 exponent to become a 1. So we know that like when we raise a power to another power, we multiply those exponents. So if I want to get this exponent to become 1, I have to think about what number can I multiply 5/2 by that would equal 1. So whatever the fraction is, you can multiply it by its reciprocal. So since this is the 5/2 power, I'm going to raise it to the 2/5 power. And then I need to do the same thing for the 32. So x to the 5/2 to the 2/5, those just undo each other, and we're left with x to the 1st power on the left side. And then on the right side, I have 32 to the 2/5, so it may be easier to simplify it if I put it in radical form. So the 32 would go inside the radical. The 5, the denominator, is the root or the index, and then the 2 becomes my exponent. I'm going to backtrack a little and just show you, like remind you of why the 2/5 and the 5/2 cancel each other out. Because when I raise a power to a power, I multiply those exponents. So if I multiply 5/2 by 2/5, everything is going to cancel out. So I can cross cancel the 2's, they both become 1's. I can cross cancel the 5's, those both become 1. So I'm just left with 1. So I'm left with an x to the 1st power, and when it's just the 1st power, I don't need to include that exponent. And then from there, I can start to simplify the 5th root of 32. So the 5th root of 32 is 2. And if you're ever not sure, like I said a few times, like just make a factor tree. So 32 breaks down into 2 and 16. 16 breaks down into 2 and 8. 8 breaks down into 2 and 4. And then 4 breaks down into 2 and 2. So since I'm taking the 5th root, I need 5 of the same number. So 1, 2, 3, 4, 5. So I can pull out a 2. There's nothing left over inside the radical. I still have this squared exponent though, so I'm going to have to square the 2. So my final answer is x equals 4. And if we want to double check that, so 4 goes in for x. If I'm raising something to the 5/2 power, that means I'm taking the square root and raising it to the 5th power. So the square root of 4 is 2, so the 5th power is 32, times 1/2 is 16, so we're good.